All right, so 4.38, right triangle trigonometry. So I'd like you to all draw out this little triangle. Draw out this little triangle right here. All right. So if we have a theta right here, our angle measurement of whatever angle we decide it to be, this is my adjacent side. Adjacent means what? Next to. And then this is my opposite side. Opposite means across from. And this is my hypotenuse. All right. Where is the hypotenuse located? Across from the right angle. And what do you know about the hypotenuse? It's the longest. All right. Of a right triangle, it is the longest. All right. So we all know these. All right. So there's a Native American princess. Her name was Sohcahtoa. All right. So we have a Sohcahtoa. Remember her? All right. So sine is opposite over hypotenuse, right? Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then cosecant's the reciprocal, secant's the reciprocal, and cotangent's the reciprocal. Here we go. So we're going to find all 6 trig values of this theta. So I have this theta right here. I have 3 and I have 4, and then I have a hypotenuse. Well, I don't have my hypotenuse. How do I find my hypotenuse? I get to use what? The Pythagorean theorem. Exactly. So to find it, I use the Pythagorean theorem. So I have 3 squared plus 4 squared is equal to c squared. Remember a squared plus b squared is equal to c squared. Remember that? All right. That crazy Greek guy, Pythagoras, remember him? Went out and killed 100 oxen to whatever god he celebrated when he found it. Remember that? All right, good. All right, so 3 squared is? 9 plus 16 is equal to c squared. So 9 plus 16 is? 25 is equal to c squared. So c is equal to 5. All right, that is a Babylonian triple. All right, so we got 3, 4, 5. Now we need to find all 6 trig functions of that theta. So sine of theta, opposite over hypotenuse. So my opposite is 4. My hypotenuse is 5. And then cosine of theta, adjacent, which is 3. My hypotenuse of 5. And then tangent of theta, opposite over adjacent, so my opposite is 4. My adjacent is 3. All right. Sine's buddy is cosecant, that's a hoe. So what is it? 5 over 4. And then cosine is secant. And the secant would be 5 over 3. And then tangent's buddy is cotangent. Ayo, so cotangent is 3 over 4. All right. Thanks, Max.
Sketch a right triangle corresponding to the trigonomic function of the acute angle theta. Use the Pythagorean theorem to determine the third side, and then find the other 5 trigonomic functions of theta.
All right, fantastic. So right now we have 3 halves. All right. So cotangent of theta is equal to 3 halves. All right, yeah, we're going to have domain restrictions on this soon, but right now we're just going to draw it in the first quadrant. Well, what's cotangent? Adjacent over opposite. So this is my adjacent, and then this is my opposite. All right, ayo. So my adjacent is next to, so this would be my 3, and then my opposite would be 2. Now, how do I solve for this hypotenuse? I use Pythag. So now I have 3 squared plus 2 squared is equal to, I'm going to call it c squared. So 3 squared is 9 plus 2 squared is 4. We end up with 13 is equal to c squared. So what does c equal? Square root 13. All right, so my hypotenuse is square root 13. So now I'm going to find my other trig functions. So sine of theta is what? Opposite over hypotenuse. So what's my opposite? 2 over square root 13. Now what's wrong with that? It's not rationalized. So let's rationalize it. So it would be 2 square root 13 over 13. All right. And then cosine of theta. Well, cosine of theta is what? Adjacent over hypotenuse. So what's my adjacent? 3 over square root 13. Well, again, it's not rationalized. So we rationalize it and we end up with over 13. All right, pretty good? All right. All right, and then tangent. Well, tangent of theta would be what? Opposite over adjacent, so we'd end up with 2 over 3. Sine's buddy is cosecant. And what's cosecant? Hypotenuse over opposite. So square root 13 over 2. And then cosine's buddy is secant. And so secant, that's a secant's hypotenuse of square root 13 over 3. All right. And then cotangent is what? 3 over 2. All right. So I want you to write out a couple things. All right. So 30 degrees is pi over 6, right? Remember that? Pi over 4 is 45 degrees. Pi over 3 is 60 degrees. Pi over 2 is 90 degrees. Remember me talking about that one page and saying those things should be very common to go back and forth? All right. So that's what this top part is going with. And then you guys know your reciprocal identities, I hope, right? They're flips, all right? Sine is really the reciprocal of cosecant, and cosecant is the reciprocal of sine, all right? They go back and forth, remember? The things that I want you to write down are these right here, all right? I want you to write down sine of 90 degrees minus theta is actually equal to cosine. And tangent of 90 minus theta is actually cotangent. I want you to write down that box, and I'm going to prove it to you. I got my green one, and I got my red one, right? You see my green one and my red one right here? See my green angle and my red angle? Got it? So whatever my green angle is, would you agree that my red one is 90 minus whatever this green one is? Because all of them add up to what? 180. Well, this is 90, right? So if this is something, this has to be 90 minus that something. True? All right. And let's just make up some numbers. Let's just make up some numbers. We'll make a 3, 4, 5 triangle. Why not? All right. So if I find cosine of this green angle, if I find cosine of that green angle, what would it be? It would be 3 over 5. Well, the 90 minus theta is over here, is it not? And so if I find the sine of this angle, what would it be? 3 over 5. All right? And they go together on these two. All right, so a cotangent is an AO. So if I find cotangent of this green angle, cotangent would be what? 3 over 4. Well, 90 minus that theta would be right here, would it not? Well, what's the tangent of this angle? My opposite over adjacent, so my opposite is 3 over 4. All right? So sines and cosines, they go together. Tangents and cotangents, they go together. Secants and cosecants go together when you have a 90 minus theta. All right?
The theta being an acute angle such that tan theta equals 3. On the values of A, cotangent theta, and B, secant theta using trigonometry.
All right, we're not using that. All right, so tangent theta is equal to 3. Well, what's tangent? Opposite over adjacent, right? So I have tangent theta is equal to opposite over adjacent. Well, what's my adjacent? 1. How's it 1? You can make anything a fraction by putting a what under it? A 1 under it. So we're going to put a 1 under it because I wanted to. All right? So if I have a theta right there, what would be my opposite? 3. My adjacent would be 1. So what's my hypotenuse? Can we do this in our head? Square root 10. Very good. All right. Just 1 squared plus 3 squared, square root it, right? So we get square root 10. So now it's just telling me to find the cotangent of theta. Well, really, we didn't even need to draw the picture for this one. What's my cotangent of theta? 1/3. All right. And then part B, it says find the secant of theta. This is where a picture is very helpful. All right, secant's a what? Ha. Secant's a ha. So it's hypotenuse over adjacent. So what's my hypotenuse? Square root 10. My adjacent is 1, so we can just usually call that square root 10. All right, pretty good. Lamont, pick somebody.
Find the values of theta in degrees in radians without the aid of a calculator.
All right, fantastic. So cosecant theta is equal to 2 square root 3 over 3. So now we know our unit circle. We just had a quiz on it, and most people did quite well on it. Well, now we're going to kind of go backwards. All right. So what value of theta gives me 2 square root 3 over 3? Now, I don't get anything on 2 square root 3 over 3. I think of 1/2 square root 2 over 2 and square root 3 over 2. Is that how you guys think too? All right. Well, what the heck is cosecant? It's the reciprocal of sine, right? Well, how did it get like this? How did it get 2 square root 3 over 3? It had to be rationalized, did it not? So what did it start out as? It started out as what? It started out as 2 over square root 3. All right? Because it was rationalized to get to that. So I'm kind of like unrationalizing it. You know what I'm saying? I'm kind of going backwards here. Well, again, I don't think of anything like 2 over square root 3. I'm going to reciprocate both of them. So what's the reciprocal of cosecant? Sine. And so I have sine theta equals square root 3 over 2. You see how we went there? All right, I flipped both of them. So now, when is sine square root 3 over 2? What? Somebody said it. Pi over 3. So theta is equal to pi over 3. 2 square root 2 over 2. This one's pretty simple. This one's pretty straight up. So what do we get? Theta equals pi over 4. All right. Pretty good. I want to do another one. Let's do you want to do a tangent or a cotangent? What do you want to do? You want to do tangent? Let's do tangent of theta is equal to, let's do square root 3 over 3. All right. Let's do that. I want to work with this backwards. Did this not get rationalized? Yes, so let's go backwards on it. What did it have to start out with? 1 over square root 3. But more than that, it was really like a 1/2 over square root 3 over 2, was it not? So when you think about it this way, when was your y 1/2 and when was your x square root 3 over 2? At pi over 6. So theta would be equal to pi over 6. All right. Now, if I did, shine bright like a diamond.